Okay, I guess it's time to start. We're actually quarter of a minute early, but let's get going, okay? So, welcome. It's good to see so many people with projects this year. If you have a project and you don't have your call sign up on the board, or your name if you don't happen to have a call sign, get it up there or else you'll be passed by. Okay? So, welcome everybody. Do we have any new members? One right there. Or people who aren't members or who are just visiting or are here for the first time or have come back after being gone forever.
W6DCC, John.
John, welcome. Good to have you. And I know this guy.
Dan Larson and Sue Baca. We're here for the first time.
Good to see you, Dan. Anybody else? Right here?
I'm Don, KJ7GS. I'm here from Springville. I've been a member for a while, but here for the first time.
Good to have you. Anybody else? I don't want to miss anybody.
Front row left.
Ah, right there.
Your name?
I'm Brayson Jara, and I'm here for the first time today because I'm just interested in radios now.
Good. We like young people who are interested in radios. Anybody else? Hiding way back here.
Sorry to make you walk.
It's okay. I need the exercise.
I'm Eamon. I'm a student in James's tech class, and I just actually passed my exam not too long ago, so KK7OSD now.
Congratulations. Anybody else?
What are you doing here?
What are you doing here? Introduce yourself.
Hi, I am Greg, and I just moved here from Wisconsin and got my license back in September, KK7OIH.
Welcome. Okay, who am I missing? Anybody else? Another one in the back. The only reason I come here is to get the exercise.
Hey, good evening. I'm Jerry Burgosh. I live in Salt Lake, and I am in James' technician class that's going on right now.
Good to have you. Okay, before I run back to the front, is there anybody back here in the back that's... Is that everybody? Okay. Anybody upgraded? We have some new class license holders. They've just introduced themselves. Anybody that did an upgrade? Okay. You're all extras, huh? I say that every month. Good. That's what I like to hear. Okay. The library is set up back here. Rick had to run home for something, but if you get a chance, take a look at the books are here. He will be back shortly. And anything you want or anything you want him to order, he can order. Okay. I guess that's it. We have a lot of people waiting to present, so I'm going to turn the microphone over to Glenn. He's got a microphone. He doesn't need this one. Okay. And it's homebrew night.
All right.
KI7NMP is first because he's doing the Elmer's Corner.
Okay. KI7NMP. We want to come up and do the Elmer's Corner.
We have 14 or so tonight, so this is going to be great. Yeah. Here you go, Jed.
Thought I had a minute to compose myself. Okay, you want to put that up so I can think about it? A while back, I started working on a 630 meter transmitter, CW transmitter, and I wanted to do a Class E amplifier, which is basically just an on-off switch. But the trouble with that is you end up with all sorts of harmonics splattered all over the place. And sooner or later, you got to do analog. Oh, push buttons. There it is. So I started designing filters. There's all sorts of stuff online for doing that. And I got all sorts of equations, and I decided I needed to wind my own coils. And started doing that, and noticed that they wouldn't hold still, and they sprung out all over. So I decided to 3D print them. And now, where do I point this? Anywhere it's wireless. Oh, that didn't work.
There you go.
So I started building coils, and about 200 later, I discovered that the equations in the ARL handbook don't work very well, believe it or not. And so I started measuring them. I bought an LCR meter. Come on. There we go. And started playing around. And many trips down to Standard Supply to buy wire. Number 22's gotten real expensive. You know, what, 2-pound roll is like 30 or 40 bucks now. So I've gone through $150 worth of wire trying to wind different wire gauges, different spacings, different diameters, different lengths, different bits of plastic on the inside to see what the differences are. And I also wanted to know what the self-resonant frequency of these things were. So I started measuring the permittivity of the different plastics and the different densities that you can do. You can do all sorts of things with 3D printing that you can't do with sintered iron. All sorts of interesting things. So I also wanted low Q. If you do a high Q filter, you end up with real sharp. And if you want to move off frequency, it doesn't work too well. I also wanted non-standard values. I don't want to have to deal with whatever I can buy in digit key. I want to make my own. And if I have to make a diameter that's 0.0376527, I'll do so, whether the printer likes it or not. And I don't want them vibrating and changing their inductance. Or having temperature change the size of the thing, or humidity, that sort of stuff. So I'm also measuring those things and trying to figure out whether 3D printing is worth it or not. So how did I do that? I printed coil forms. I wrote some programs that generate a constructive solid geometry description of a coil form, which is really a helix wound around a cylinder with the helix subtracted, half of the helix subtracted from the cylinder. And there's a program called OpenSCAD that lets you do that sort of thing. Unfortunately, it's either written in Java or Python, and 8 hours for a reasonable sized coil is not unheard of. So also optimize turns and length, and then try to build the polynomial equations that allow me to decide if I want 5.1 microhenries, what's the optimum size for that coil with Q and so on. Oh, wrong one. So here's kind of what it looks like. The CS3 description, converted to STL so it can run on virtually any printer. I wore mine out, so I had to buy a new one halfway through the experiment. And so that's the new one. Unfortunately, it comes with lime green. And the thing I discovered after a month of this is that no matter what color you pick, after about 2 days, you're really sick of that color. So print them, wind them. If you're winding number 14 wire, you quickly discover that your fingers aren't strong enough to get that wire on there. That's nasty stuff. And number 28 is easy to lose track of. And it's very much like knitting. If you're winding a 40-term coil, you get to 39 and somebody says dinner, you start over. Oops, all right. So I've written a random paper studying that, and you can find that online. It's 60 pages full of all sorts of gratuitous mathematics and graphs and so on. Oops. Oh. Ah. A graph. Just coming to the good part. Looks like a fossil. It wouldn't happen to be a fossilized inductor, would it? That'd be cool. Well, anyway, I printed about 70 or 80 coils with fixed spacing, and it turns out the ARL equation really expects that the turns that you're putting in there are the same distance apart as the wire diameter. And if you do anything different, it starts to go wrong. And if you're doing coils that have big spacing, say you're going to do 1,000 volts through them or something, then it really gets bad, 20 to 50% error. And so I do a genetic algorithm to fit 5 variable multivariate polynomials to the data of around 200 coils, and I've got a bunch of machines busy cranking away at that. You can almost hear them, they're real noisy. Anyway, questions?
So do the coil forms actually have little indentations where
Yes.
the wire goes?
Yeah, I've got some here.
Yeah, I saw some of those. You've got to see.
Oop.
You've got to see some of these. They're perfect.
That's not a perfect one. I can't throw any farther. My arm isn't working too well. Anyway, I've got some here. By the way, you can buy plastic with iron powder in it, which has a, not permittivity, what's the other one? Anyway, it's about 2 ton, right? Permeability of about 2, as opposed to pretty much 1 for plain PLA. Oh, there you go. So here's one with the ARL equation in dots and the 0.375 diameter, 385 diameter coil with 1 inch length and 1 to 30 turns, which means the spacing between the coils changes, which the ARL equation doesn't work very well for. And these are the other ones over here. And it's a little bit better because the spacing is fixed. Other questions? Yeah.
Yeah, I need somebody to, like I said, I could get in contact with you to help me wire a donut. I got some wire, and I got a donut.
Oh, this isn't donuts. No toroids. No toroids need apply. Oh, you got to do that one yourself. They're nasty. Yep. No, sit there and wind it, practice. Use yarn to start with or something. or buy a lot of wire.
Is he doing one remotely?
Well, might not work the first time.
What's that? He's planning on it. Okay.
There you go. Okay.
Include him in. All right. Well, that's quite the Elmer thing. I think that's an extra Elmer there. All I did is take a piece of sewer pipe, wrapped the wire around, and used hot melt glue and stuck it up in the tree. You're good. Very good. Okay, are we ready for anybody that's online yet? Or?
Yeah, let me go ahead and find out real quick.
All right, we do have a few distant visitors here.
All right,
Let's try and see. Oh, Ron Jones, I know him.
all right, so is anybody here ready to do a presentation? Anybody have a presentation ready yet?
Yeah, we're talking online. If not, let's jump right to WA7JOS. Let's see what you built out of wood this year. Oh, plastic. Okay. Outstanding. I'm going to hand you this mic when you get down here. So we'll get the online next one. But we have about 15 contestants tonight, so.
Yeah, so better keep it short.
Yeah, better keep, watch your. Okay, here you go, Chuck.
He's trying to kill me here.
Yep.
Okay. You got my PowerPoints there yet, James? So it's Homebrew 2023. Okay, getting the PowerPoint loaded up here. I wanted a little volt ammeter to go with my RV to keep track of the solar panel on it. And some of you with Go kits and stuff could probably use something similar. So we get the pictures up here in a minute. But these little tiny bricks are dirt cheap. I think you can buy them lots of places for less than $2. Measures voltage and current up to 10 amps. And so.
Okay, there we go.
Okay.
If you want to change slides, push down.
Okay. So here's a picture of it, and I printed a 3D package to put it in. And what do I have to point it at? There's the back side, not very interesting, but this little snap-on cover that fits in there. And with the cover removed, there's the wiring inside. So the plus just goes straight through from one side to the other, and the minus goes through the board and has a little shunt in it, so it measures millivolts and converts that to current. And that only works in one direction. If you go the other way, that's negative current, and the meter can't read that. But this turns around so that you can use it. So here's my setup with the RV. Got the battery, the solar panel, and this little box down behind it, which doesn't have to stay there. It's Anderson power pole connectors, so you can just plug the solar panel straight in, or hook this in series. And if you hook it up this way, it measures charge, and you just turn the meter around and you can measure discharge. So there it is, and because it scans, the camera only got 2 digits here instead of 12.4 volts at 0.08 amps. That's what it says. And so $2 for the meter, 30 cents for the plastic. The expensive part was the Anderson power poles. I'm probably about $5 into it. Here's what Quicksilver sells for $50. Basically the same thing. Okay, next project. The club has purchased a 6-meter beam to add to Leamington. That'll go up in the spring. What? The Leamington site. That's our remote base station. So Here's what I built 2 years ago, a 2x1 switch that goes at the top of the tower to switch between the end-fed half wave and the beam. But if we add the 6-meter beam, now I need a 3x1 switch. So I found this remote switch at a swap meet last year. And so this part goes down at the bottom, and you put a voltage on the coax, and that tells the relays at the top what to do. So here's the top part of the unit. And so I went inside the control box and modified it to pick up those voltages. It puts on nothing, plus 12, minus 12, or 12 volts AC is the 4 combinations of relays. And added this connector on the back. The interface that's already down there has some relays on it, so we just hook that up to the relays and everything continues to work as it already does. Okay. And then the 6-meter beam recommends that we take the feed point from where DE1 is up there, run it off the reflector end of the beam, and then put a 5-turn choke on it with the coax. And, you know, I could just wind up 5 turns and put some tie wraps and tape around it, but what fun is that? So I decided to 3D print it instead. So here it is. Got a coil form, a little bigger than Jed's. Holds 5 turns of LMR 400. And the square hole fits over the boom, so it's all one integrated unit. That's 32 hours of printing, not including this 12-hour failure that delaminated from the base plate, and it's a whole lot thicker on one side than the other, and it's all warped. And attempt number 2 turned into a lace curtain. Not sure what happened there. It's like it didn't inject enough plastic.
How strong is that?
After 32 hours, I don't want to find out.
Let me know when you're ready to go back to the PowerPoint.
Okay, I am, yeah. Okay, so this finished about 12:30 this morning, a.m. And there it is on the boom. Different angle. And that's pretty much it. So. Any questions?
All right. Well, and I'm going to compare that to what I did. I used the chop saw. It took 3 seconds. The sewer pipe came right off, and that went the coil. No, it's okay.
But you don't have a square hole.
I don't have a square hole. Jed.
The design is on this month's cover of Microvolt.
Oh, the design is on this month's cover of the Microvolt. So.
Oh, excellent.
See, there you go. Okay, so now are we ready for Ron? Remote? Ron Jones, the remote?
Yeah, we can go ahead and get
Okay.
it up.
Let's see if you're ready, Ron. Okay. You want this?
Ron Jones, are you there?
Ron Jones, are you there? K7RJ, WA7X. That's Dan. Are you ready, Dan?
I can hear. I can hear.
Female voice, it's Elaine.
Okay, cool.
Okay, we ready for Ron?
We just don't hear anything. We've got our audio maxed out and don't hear anything.
It's real, well, we hear
yeah,
stuff.
We hear
it's,
you.
It's extremely low audio, really, really low. We have to strain to hear it.
Yeah, I'm sorry, technical error here, but just go for it, Ron. If you,
I hear you say, I'm sorry if I stick my ear up to the loudspeaker, I can hear you. That's about it.
Gary asked me to do a presentation.
okay, if you have one.
Dan Judd, N7QXB. Are you ready?
Oh, well.
Yeah, so we have you on the main projector here if you have a presentation.
All right, I'll go ahead and give it.
Okay, we're ready for you.
I'm going to share my screen here. You've got to enable my screen sharing.
Good to go.
Okay, let me get to the right place here and okay, this is hold on here, I'm getting to the right one. And can you see my screen?
No.
Okay. Okay. Share. How about now?
Perfect.
There we go. Okay.
I recognize
for
that.
The past month, I've been up to my eyeballs in a tower project. And the way how this all, can you hear me okay?
Yes, sir.
All right. Okay. So, I stumbled upon this gem on KSL's classifieds a while back. And I grabbed Glenn Worthington and said, let's go over and take a look at this thing. And it was too good of a deal to pass up. So I spent the next, come on here, where do I? Give me a chance, there we go, okay. I just had to figure out how to get to the next screen. Okay, so we took a look at it and decided it was probably a good deal. So I spent the next 3 days tearing the thing down. So it was a high gain tower. Their 52-foot version. It was made back in 1988. It was originally purchased by a guy by the name of Gary Adams. Does anybody in the room know Gary Adams? He died in 2022, but looks like he was probably a pretty active ham, a while back, but not sure if anybody knows him. I know Hal Blankenship knows him. He was his boss out at Utah Power and Light when he worked there. So the tower took 3 days to take everything down, and as you can see, a couple of bolts and it folded over. The first thing I did was able to get the high gain Explorer 14 3-element beam with the 40-meter package to all dismantled and hauled it home. And then came the tricky part of laying down the tower. And the way how we pulled that off was a couple of straps of webbing around the chimney and a little bit of my previous rock climbing experience and know-how, and we basically belayed the tower down. Then after it was down, we started hauling stuff home. Eventually, it took about 5 of us, but we all picked this thing up, hauled it out of the backyard, up the hill and out to the curb, good friend of mine brought a trailer by, and we hauled it home. And that's a picture of what the base looks like. An interesting side note, High Gain, their earlier version of the manual for the tower, talks about a pad about this size, which is 32 inches by 32 inches by about 42 inches deep. Well, their second version, they bump up the concrete considerably. They go from about 1 cubic yard to 2.5 cubic yards. And this was, it was originally, these towers were made by Telex High Gain. And once I got a building permit from Holiday City, the next step was to start digging a hole. And so here, this was the first day removing the sod. The base showed up, and was able to make sure that it did fit the tower. If you ever do this, you always want to make sure that the base fits the tower before you put it in the concrete. And continuing to dig, let's see, on the third day, got to the point where I couldn't do it by myself, so I drafted my brother into the project, and with his help and a demolition hammer with what's called a clay bit. It looks like it puts a little heavy-duty spade shovel on the end of your demolition hammer. I was able to finally start peeling away the holiday clay in a reasonable fashion, and it worked fairly well. And so now we're down to about 4.5 feet. We've got another 1.5 feet to go, and then at that point we'll be able to form up and suspend the base of the tower, and then be able to pour the concrete. And that's it. I'm going to stop sharing here if I can figure. There we go. Stop share. I'm going to go back to just showing you my face here. I wanted to show, this is one of the side arms for the tower. It has 3 of them. It was the way how Gary Adams had it was he had taken an old bicycle tire, cut it into 3 sections, and that was wrapped around the coax and the rotator cable, and that then went into this notch here, and that's was taped off. So what I came up with is I really liked what Chris out at KF7P, Metalworks does. He's got some arms that he does where, you can see on the other end here, it just is a U-bolt to the leg of the tower. And you have the 3 of them so that it holds the coax and the rotator cable out away from the tower. And Chris's version of this, the 2 lower ones, have a spiral wire that creates an opening that allows you to put cables in and out, and as the thing goes up and down, as the tower goes up and down, the coil, for lack of a better term, just simply goes up and down, and eventually all of the cabling ends up on the ground. Well, what I did was I pulled out my favorite 3D modeling software, and I modeled up something that would go with these arms. And this is what this is just simply a little hoop that goes on the end here, so that this will allow me to do the same thing as what Gary's Chris's KF7P arms will do. And the only thing is this first version of it may be a little small. I may have to, this is 2 inches in diameter around the hoop. I may have to go up to about 3, I think, maybe to get it so that the cables can go unimpeded. But that's where we're at on the tower project, and I think that's all I've got.
All right, are there any questions on that? That's pretty impressive, Dan. Yeah, go ahead.
How was the process of getting the permit in Holiday? How did that go?
Well, Dan, do you want to tell them how the process went, or do you want me to tell them?
Could you tell us how the process went
in Holiday?
Building permit.
For the permit.
Yeah, actually, I was very pleasantly surprised. The first thing I did was I just did a Google search on Holiday City and ham radio tower. And it took me straight to their section of their city code, of their building code. And there were basically about a half a dozen requirements. One, the tower couldn't be over 64 feet tall. You can't put it in your front yard. You can't have the tower or any portion of the antenna overhanging onto your neighbor's yard. So just some common sense stuff. And so they also require you to have a $1 million liability policy, so in case it falls over on your neighbors. I basically put together everything that I needed as far as proof goes, and went over to there. They initially wanted me to do it online, but I figured talking to a person face to face would be beneficial, and it turned out to be very much so. I got over there, and one of the people there behind the counter, his name's John, and lo and behold, he turned out to be a ham. And he's currently got a technician's license. And so the first thing he said to me is, he said, "Oh yeah," he says, the only thing that we regulate is the actual foundation." He says the FCC is already, the rest of this stuff is basically what the FCC has suggested. And so it took me about an hour of talking to him, and $39.62 for the permit, and I walked out with the permit. So yeah, no board of reviews with the planning commission, no mandated meetings with neighbors or anything else. It was just, very straightforward, and it was very anticlimactic. I'd really worked myself up, wondering, how I was going to pull this thing off, and, it was just a matter of getting your ducks in a row, Holiday City was great, so I can't say enough. The only requirement that I have is that once I get ready to pour, I need to call up the inspector, and they come over and take a look at it and make sure that I've got everything, the holes the right size, the right depth, and the base of the tower is being suspended properly, and it's not sitting in the dirt down below. So now once I get that approval, then I pour the concrete.
Thank you.
All right, thanks, Dan. Very impressive. Let's get the next person coming on up, KD7NZA. Come on up, and we'll get you going. Yeah, I was pleasantly surprised. I live in Mill Creek City, and I upgraded my power from 125 amps to 200, and the inspector came by, looked at it, looked at my stuff, and says, "Oh my gosh, just send me pictures." And that was it. Yeah, all done. All right, here's the mic. Go ahead, and we're going to have to kind of speed up. We got about 15 left, so
I'll be brief. So my project was to build me a radio go box. My inspiration for this was taken from a fellow up in Canada, VE6LK, and he is heavily into emergency management and communications. And so I kind of took my inspiration from him, and then also a little bit from K8MRD radio, a YouTube video. So what I did is I bought the Apache case from Harbor Freight, and then I put in an 891 Yaesu HF radio, and then an ICOM 5100 2 meter, 70 centimeter radio. I did place these on a piece of plexiglass that is supported by 4 bolts, so that if I need to, I can take it out of the case and set it on the table. The hardest thing I've had right now is I didn't get time to take care of my cable management, so I've got cables running everywhere. But it's still a work in progress, but I will go ahead and get that finished up as soon as possible. Are there any questions? I don't have a battery in it yet, but I do have a battery go box that is a Goal Zero 1000X that I can carry, to use that. So,
Thank you. That looks like a great project. I'm looking at the screens here, and I think we're about 90 degrees out of phase. I'm actually not purple, but I suspect that's not the case online from what I can see, so that's good. So next one, N7JZU, come on down. All right. It's Gary. All right, Gary, here you go.
All right, thanks. James, you got that where it says Go Box? All right, I made a 2.5 men Go Box. It's sitting over there for you to see, so anybody wants to look at it after the meeting, you're welcome. I'll stay for a little bit. Go ahead and start that. So anyway, I made this watching a lot of YouTube videos, and I took a lot of ideas from different videos, and this is what I come up with. A lot of the equipment, about half of it I repurposed that I had already, and the other stuff I bought brand new. And whenever you're ready, James. Yeah, it's just JPEG pictures. So a little bit about the box. It's a Gator Box 6U, so it's 19 inches deep by 19 inches wide, but usable space is 17.5 inches on the shelf. Okay, then that's the box when I received it. Go ahead, next one. All right. Okay, that's the inside of the box without any shelves. That's with the two shelves. The bottom shelf is 19 inches deep. The second shelf is 14. There's my 897 set in. By the way, I made my own brackets to mount everything to get the equipment that I wanted in there. I had to custom make brackets. There's this radio here is a Yaesu FT 300. It's 70 centimeter, 2 meter. I'm going to be using that for APRS. My 897 is a shack-in-the-box receiver, so it's got HF and 2 meter, 70 centimeter. And I've had that since 2009. There's the back of the radio with some of the cable. The front of the radio, two radios together. I put a Red Runner power distribution. Custom made my own cables to keep cable management short. There's the Red Runner again. Right here is the battery. That's a 20 amp hour Violino battery. Strapped. That's the only thing that's strapped down with ties. Everything else is bolted down. This is a LDG 250 auto tuner. the reason I went so big with that, because I like to work FT8, FT4 with digital, and it's you need the capacity for digital since you're working with the full wattage. This is a repurposed Palstar SWR meter. Over here is a power supply, 30 amp hour switching. There's the, this is the SWR meter was a mobile meter that I purchased years ago. I shortened the lead on that and bolted it in on the second shelf. There's the box to all put together, powered on. I put a 1-inch drawer in it, and I put the LED lights on the bottom of the drawer just for the wow factor. So you can see all the cable. And there it is, lit up and everything done. And then on one of the lids, I put a steel plate in I got from Lowe's, and I've got a mag mount signal stick antenna that I can. It's on a 20-foot piece of coax I can stick out and work for APRS when I want it, and that's what I got.
Thanks a lot. In an interest of hurrying up, as the way that this has been ordered in, Jerry's going to be next, and then follow where you're at, and then it goes back up this way. Let's get in the queue and see how fast we can go. Unfortunately, we don't have an infinite amount of time, but we have a wonderful presentation. So, Jerry, here you go.
So mine's quick and dirty, and the premise on this battery box was you should come to UARC meetings in person and win stuff that many people would call junk from the door prizes. So this is a battery box that weighs about 5 pounds. It's a 30 amp LiPo battery put into a case that you will regularly get as a door prize here if you come. And so just a switch and a combined volt and ammeter, and the ammeter is hooked up to the load side, of course. And then I paid a little bit of money for a PowerWorks USB plug because they're about the quietest one you can find. And as Clint and I were discussing earlier, there's no such thing as a really quiet USB. Then a cigarette lighter plug and power poles. Charge port is SAE on the side. Both are fused inside so that I can charge it with either solar or with my LiPo charger. And again, all of the LEDs and everything are in red because not only do I use this with ham radio, I run a very large telescope off of it. So that's my project.
And how much did that battery cost?
So the battery is $199 list price. Amazon Prime Day, $39.95.
Whoa, well.
And something similar with a heavier battery was at the divisional show in their swap meet for about $95. And that's about the same price you get it at PowerWorks.
There you go. I just spent $500 for a 30 amp hour lithium ion for my Tesla. So who's the next one here? TPH? Oh, you got him? Mark. There you go.
All you have to do is wake me up. Okay, I don't have a sissy video. I got the real deal here. You take this piece. I got that one. That's good. Okay, I have a little section of tower here. This is made by a company called Aluma Towers, and it's extremely lightweight. For how small it is and how little it weighs, it's actually surprisingly strong. But there's a problem with it. Can you see what the problem is? Not that it's too short. This is just one half of one section.
It's not climbable.
You cannot climb it, right? So the only way to use this then is to fold it over. When I got these sections, actually got 48 feet of this stuff. And there is evidence on one of the sections of a fold-over hinge. The problem with that is there is no place in my yard where I can put it, where I could fold it over from the bottom and have it still be in my yard. So there's another problem. The way I got around that one is I built a hinge to put in the middle of it. And that's this right here. I built it in my little machine shop. Show you how it works. It's bolted together right here. Set this down. Okay, we have this little spacer to keep everything in alignment. Little spacer to keep everything in alignment. And here is the hinge. So it folds over like that. I can fold it over. Put this in the middle of it now, and if I want to go the full 48 feet, which I'm not going to do, whatever. If I put it in the middle, then I can fold it over, and it's still in my yard. There is one modification I might make to it. I might redesign the top section of this and build it so that I can place the rotor down here at the hinge rather than at the top of the tower, because as Glenn can mention to you, by having the rotor at the top of the tower, when you try to rotate the antenna, it torques the tower. So by getting it down as far as you can, I think you have yours way at the bottom, right? Yeah, so then it doesn't torque the tower. And being as it's a tiny little tower, I think that might be a good idea. Anyway, here it is. I built this in my machine shop. You can come down here and look at it if you want. And that's it. Any questions? Yes?
So the reason why you fold it is just so you can work on things?
Yep, just so I can work on the antenna. Yeah, with the tower, if the tower was all the way up, the only way I'd be able to even put an antenna on it would be to hire a man lift and bring it. Yeah, so this way I can fold it down. It's still in my yard. I can work on it, put it back up. Yes?
Do you have to get a 24-foot ladder to get up to the hinge?
No?
How does that work?
Well, if I fold it down, the antenna portion of it is all the way down on the ground. So I just walk up and do it and work on it.
You have a hinge at the bottom and a hinge in the
No, just the hinge in the middle.
So how do you get up to the hinge?
Yeah, you're right. I'd have to have a ladder to get in there to unbolt it. That's the only thing. Yeah. Once again, I'm not going to go 48 feet. I run a hex beam, and actually a hex beam at 48 feet makes the takeoff angle go really high. So it'll actually be about 35. And I will choose the position for this at some location where I can fold it down, and it could actually be low enough that I could get to it with a step ladder. Okay?
All right.
All right.
Hey, clearly, he's not in the city of Holiday. He can't fold into a neighbor's yard, so Dan had an advantage on that. Okay, come along. Next one is
K7HSR. My name is Scott, and I'm a relatively new ham. I've only been doing this for a little over a year. And Jerry is one of my Elmers, and she lent me a couple of antennas. And you know, the wife wasn't entirely sure about this hobby at first. You ever get that feeling from your wife? So I started with one of these, and some of you have probably seen these. These will help you pass your antenna through a window and still be able to lock the window. Well, after a while, I realized that I was actually going to be serious about this hobby. Well, this is not my presentation. This is where I started. So I realized I was going to be serious about this hobby, and I decided I wanted to put an entry box into my house for my antenna, the down button, thank you, for my antenna. This is the corner of my house, and this is the window that used to go through. And the idea was we were going to put a box, an entry box, on this corner of the house. And with a little bit of help and pushing the right button, okay, at part of the project you had to drill a hole to get the wires through. This is the hole on the other side inside my shack, and you can see it's about a couple of feet above. This is plastic here, but this is actually the top of my workbench. And this is a piece of conduit that will go through the wall from the outside into the shack. I'm moving a little quickly here. This is the back of the box. That's the hole where the wires go through. The resolution probably is not good enough, but I weather stripped all around the back of the box before mounting it on the house. And the next picture. This is the box mounted. Somebody mentioned KF7P earlier, and KF7P, Chris, is on the west side of Salt Lake. He made this box, and I love the design of his products. You can order this with as many holes in the bottom as you want. You can have the entry hole top left, bottom right, wherever you want it. They're not cheap. This is the first couple of pieces of coax that I ran through, the grounding strap. And I also ran some paracord, because I know there's going to be some other wires that are going to want to be pulled through this box at a later date. So I was just planning in advance. This is where the wires come out through a nice little scoop mount on the wall. And this is with the ground plane. It's hard to tell with the color in the background here, but that's a copper sheet on the back of the lightning arresters. The antenna lightning arresters are in the lower left. There's a lightning arrestor for what will be the rotor control cable in the upper right. And this is with the first antenna wire mounted to that right-hand arrestor. This is the final box mounted on the outside of the house. Now, let me ask you all a question. Simple project, right? What do you think was the toughest and most important decision of this entire project? The what? Drilling in the house. That was not the toughest thing. It was not easy. Color. How to hide it. Who said color? Getting my wife to pick the color was the hardest and the best thing that I did. Okay? Because she bought into it by picking the color. And yes, you can buy a box at Lowe's and Home Depot and get a steel gray or whatever. But making your YL happy with the right color box, it's worth the price of admission from KF7P. Chris also has a nice grounding bar, which I mounted behind my bench along the wall. On the far right is that grounding strap that goes through the wall, out to the box, connected to the box, and straight down to the ground rod right below the box. And that's my presentation. Any questions? Yes, sir.
Why did you choose copper instead of like a quarter-inch plate aluminum?
Because Chris makes his with copper ground plates. I didn't choose it. It was designed that way. Yes, sir. How did I drill it? With a 9/16 inch hammer drill and a 2 1/4 inch masonry bit with a pilot bit borrowed from my Elmer. Any other questions? And by the way, it works great. Thank you very much.
This is a comment, everyone needs a set of brick and concrete, both saws, ranging in range.
All right. Oh, okay. You're gonna. Okay, I'll have him turn that around. All right. Thanks a lot. And then James, he's gonna shoot behind you here.
K7AIX here, and this is my grandson, KK7JEV, just enough voltage. And he's going to take the first 30 seconds, and I'll take the next 30 seconds.
All right, thank you. This is a power supply that me and K7AIX worked on. Surprisingly, at first we used a different internal power supply. I don't know if you can see it, but it produced RF voltage that messed up the DX10, but now we have a different one, and it works quite well. And let me turn it on real quick. Now with this light bulb, it should go at around 17 amps. Yeah, 17 amps, and that's quite bright. And that's about it for me.
So KK7JEV, he jumped on board. He's been doing this less than a year, and he's received his general, and he knows more about HF than I maybe ever will. He's doing an incredible job. And before he received his license, I made this and gave it to the three brothers. He has two brothers, and it's just a Jacob's ladder with a remote control. Go ahead.
Now this isn't quite anything like the one he has at home. It's bigger and better.
So ever since I gave him this, he jumped on radio big time. So maybe if you want people to do radio, give them a Jacob's ladder.
Very good. That's ready for Halloween as well. All right. And at one time, they had a bunch of those power supplies out at NPS for $10 a piece. And I got a few of them. But anyway, they're expensive otherwise. So who do we have next? KN6KRB. Come on down. And we're trying to hurry through here, so see if you can do a quick shot. And the faster you are, the more prizes he gives you. So just a little clue here. An outlet. Yeah, there you go. And by the way, to get your wife to like this stuff, get her a ham radio license. She's KI7DX, an extra 25 years, and no problems. So here we go. KRB.
Yes, I took one of those QRP radios. You know, a QRP radio. And I made a Morse code keyer because most of them are so expensive. So I made my own. I used a couple of little pieces of a dual-sided circuit board with copper, and used some brass sheets. You know, like this. Little brass sheets, and add a little dab of solder with soldering gun. There, put a brass sheet in between two pieces of double-plated circuit board, and put another brass sheet right here and another brass sheet there. And I cut all this circuit board on a cutter, a cutting board. So, very easy to make. And I did is I made a little sharp edge in there to try to get, so I don't get you like scratchy kind of code. So I'll demonstrate the code.
Want me to hold that for you while you do it? Oh, there you go. Good idea.
Hey.
Thank you. That's a nice little keyer and a great little rig you got there. Okay, I think it's Clint who's coming down here with a big box of things, and this will be exciting for sure, or at least this weekend it will be. So go ahead here, Clint. You want the mic? Oh, okay. You're gonna unload the bucket.
All right. How many of you are aware that in a few days, if you look up at the sky, you'll get a ring burned in your retina? So this is one of the types of eclipse you can never look at it ever directly without any protection. But anyway, there's a PDF on there. It's only a PDF on the thumb drive. What? Yeah, that silver one. Yes.
Yes, that's correct.
Mm-hmm.
I'm just looking for your PDF.
Okay. Let's see. It's probably there. It is. It's the Eclipse TX.
Oh, thank you. Sorry about that.
Oh. Anyway, you probably heard about ham radioactivity during the eclipse, and what happens during the eclipse isn't quite known exactly how it differs from what normally happens when the sun goes down, in which the D layer, I can't draw here, I didn't have time to do a drawing. The D layer disappears at night and the F layers recombine, so it goes into day mode, into night mode. But during the daytime, one of the reasons AM stations or lower bands go short is that the D layer absorbs stuff and can't reach the F layer to bounce it. With the night when it gets dark, that D layer immediately goes away and things start bouncing from a great distance. But how do you measure what's going on that way? Well, one of the ways you do it is something like this. Bring up the slide again. So at the Northern Utah WebSDR, it has big antennas, a lot of computers. I built this box here, which will inject into the antenna system for every band, 2 signals. One signal that has the GPS that's phase flipped every second from GPS, another one where the carrier is constant. So I have amplitude and frequency references down to 10 to the minus 10th or better, which is at 10 gigahertz, which is less than 1 hertz error at 10 gigahertz. In other words, at 10 megahertz, it takes about a half hour for the whole cycle to slip or more. And that's at the Utah SDR, and off somewhere over here, there is a receiver that is inhaling all of HF and recording it to hard drive, which is, in case you're wondering, is 7.7 gigabytes per minute of storage space. So with the 3.5 terabytes we have, we can record roughly 6 hours of 0 through 30 megahertz. And we will be capturing everything in 0 through 30 megahertz, from submarine, what?
Where did you borrow that from?
Oh, you can buy it, it's $150. So, yeah, but it's on a fast computer. So this doohickey injects the calibrating signals into it, plus it's GPS locked and everything else. On the other end, you'll have something like this. I'll go ahead and lift that up. This transmits on 8 bands simultaneously. And if I flip this here switch, I generate 24 signals, 3 on each band. Some of them, the main signals are FT8, which is kind of like Whisper, but gives more information on Doppler shift. But the other signals are also GPS locked. They're in here. The GPS reference is in this board. Go to the next slide. Let's see, what do we have? Go to the next one. I inconveniently made it PDF. So it's, there we go. Okay, it takes the signal at 45 megahertz, which is the master signal, converts it with all these boards down to individual ham bands. Next slide. And what's not obvious here is these all have synthesizers on them, and they're locked to this here 10 megahertz atomic reference. If you've never seen an atomic frequency reference, here's one here. It takes about 2 amps to run, takes about 3 to 5 minutes to come up to 10 to the minus 9th, and another half hour to get to 1 hertz within accuracy on 10 gigahertz. Now, if you ever wondered how you combine multiple transmitters onto one antenna, it's these boards. These boards, there's a whole bunch of boards that I had to lay out and build. So these are high Q selective filters, and they allow me to multiplex onto the same antenna. Go to the next one. And what you see in the board is how they're arranged here. So these are the amplifiers. These are the combiners. This is the thing that generates the signal at 45 megahertz. Go ahead. And this thing here is another, a friend of mine made these. They're called the Beacon Blaster. This is a modified version. It generates the signal at 45 megahertz that is GPS locked. So out in the field, we'll be generating known signals with accuracy and known precision within sub-millihertz at 10 meters. And that, by having that much accuracy, we can rule out what our transmitters are doing, and all the measurements we make will be based on what the atmosphere is doing to our signals. And the advantage of having multiple bands is that you can analyze how things are different, how affected differently. And there will be several receivers spread across the country and the world, just like ours, that is inhaling all of the HF spectrum at the same time. And the hope is that working with some of the folks at University of Scranton with HAMSI, we might be able to be lucky and make 3D tomographic real-time maps of what the ionosphere is doing during the eclipse, possibly. The data might be there to do it, but if we can tease it out and somebody smarter than us can do it. But you don't know. You collect the data, you know how good the data is, you know what the data is, then you might be able to do something with it later. Anyway, that's what I'll be doing this weekend, somewhere in the middle of the desert of Utah with the multi-bands antennas. Yes? The lowest bands are running about 10 watts. The highest bands are running about 3 watts. Total output power of this thing is about 100 watts. So this thing takes, there's 2 fans on here. This thing takes about 22 amps to run this thing, because there's a lot of inefficiency, because everything has to be linear, because I'm sending a crap ton of carriers out. So anyway, any other questions? Yes?
What should we be doing during the eclipse as ham radio operators at home?
Having fun. I mean, do what you want. I mean, it's an opportunity to notice, at least within the eclipse zone and areas affected, you know, so what you'll probably notice is during the eclipse, it'll be as if it's sunset. So 80 meters will probably get good to California, something upper mid Pacific Northwest, things like that. The high bands may go away, may not, I don't know, because the eclipse is local, in quotes. So in Europe, of course, you know, it's not going to happen, nothing's going to happen, but I think actually the main thing will happen is the low bands will come alive. We'll be, on part of our recording, we'll be recording AM broadcast stations all over the area, and we should be able to analyze the Doppler shift on those, because a lot of them nowadays are either super stable or GPS locked. Any other question? Thank you.
All right. Very impressive, Clint. Clint was with me at the last total eclipse in Idaho. We were very fortunate to have a brother-in-law that lives square in the middle of the path, and the total eclipse is unbelievable. And that's where some of this stuff started to come out. I know that a friend in Oregon is going to try to listen to KSL AM to see if he can pick it up, because he can at night normally. So maybe we can pick up KNX out of Los Angeles or something like that. So we're KJ7 Gulf Sierra. Let's have you on up and get her going.
As quick as I can.
Okay.
Yeah, so I live in an apartment. James, are you able to bring the stuff up? Oh goodness, this one right? But it's right here. Yeah, it's in there. Okay. Yeah, I live in an apartment, and so I'm kind of limited in HF capability. So what I did was get on the Leamington remote, and if I can see the instructions for it If you could scroll down to page 29, let's see. It would be RC4 client. Yeah, that one is one of them. Oh, it's a UARC remote. This one. And slide down to 29. Anyway, I'm reading through the instructions to see how it works. Fairly new at it. And CW operation using a local paddle. Can I use this with a straight key instead of like a iambic keyer? And I had the harebrained idea to take the cheapest of the cheap, $6 and change straight key, and marry it up to the high-tech remote internet HF station. So the problem was the second sentence there. Doing this requires that your local computer has a working serial port USB to serial interface is fine. What's that? Okay, KK7DV to the rescue. He got a hold of me and he sent me a couple links, and that's the other item here. Let's see. It's the other document. Anyway, one of those links, I did some research too, came up with a little PDF file, and if you can find it there, it's just a little circuit you can get for $6 and change off the internet, okay, and you have to buy a few parts for it. Yep, that's it, and bring it on down. That's enlarged view. This is what, 1.5 inches by 3/4 of an inch. So had to buy some parts for it and got those put together, hooked it into the remote, and it worked. One more picture. It's the photo of the remote screen. It's just a JPEG file. That's it right there. Okay. Okay, yeah, sure. Anyway, on the remote, when you look at the screen, you'll see a little tab at the top that says Control Devices. That'll be the second one over. But once the remote sees what you plug in, it'll come up with the COM port. It'll turn a beautiful shade of purple, and you turn that thing on. You adjust the rest of your parameters, and you're on the air. So this morning I got up enough nerve. I had not used straight key for about 30 years. And this morning, about noontime, I made my first Diddy Bop contact into Germany. So I'm happy. So that's the project. And KJ7GS back to net.
Okay. Have you tried it on my remote, the WA7X remote?
Yeah, can I?
Yeah. Well, if you're in New York, yeah, you can. So, Mike, you're next, right? Yeah. All right. MTI. Oh boy, here we go.
Some time ago, we had a presentation at one of our meetings by AI3W, Rick, and he presented on his mag loop antenna. And I thought that was a pretty cool thing he made. So then my good friend James here loaned me a mag loop antenna that he had set up for 6 meters, and that worked out pretty good, so I decided to make my own mag loop. And I've got this one for 10 meters, and I don't have the capacitor plugged in it, but I went ahead and made it. James helped me tune it up, and it works really good. We used it last night on the 10-meter net, and Linda, did it work? Loud and clear, she says. So this is my project. I did my call sign in the with my Is that got a good view of me? There, make sure, get a good picture. I cut out the call sign at Make Salt Lake with the laser cutter, so just to add a little bit of a thrill to it. A frill. What's that? Yeah, there you go. Exactly. Okay, any questions? All right, well, thank you very much.
And I suspect it's highly directional because I didn't hear him as well as Linda did. And I'm actually a little closer. So here you go. Gary. Whoa. There you go, Gary.
Good evening. My name's Gary, and I like to build stuff. And some of the stuff I build ends up being overly complicated. Some of the stuff just doesn't work very well. But most things are overly complicated and don't work very well. So tonight I want to show something that's uncharacteristically dead simple and reasonably effective. This is the matching network I made for my antenna. Can I get the slides, please? Okay, next one. Okay, so yeah, there's my antenna. Oh, back to the, there you go, that one. That's a random length. Sure, I'll give it a go. Okay, so that's about 35 meters worth of wire up in my attic. Goes up through the roof, along underneath the rafters, around the corner. And so that's something I make that doesn't work very well. You can probably guess why. One of the problems with that is it's not close to a 50 ohm match on any amateur band. So I measured the S11 of the antenna on a nano VNA. If you don't know the nano VNAs, James KK7 AVS did a Elmer's Corner presentation on it. I think the video is on the web. You can learn about the analyzers. Anyway, there's the return loss and Smith chart of it, and 50 ohms would be in the middle here. It doesn't get very close, so I need a matching network for every single band. So I looked around my junk drawer, and I had the best switch I have is a dual pole 6-throw switch. I expect I probably must have gotten that from Standard Supply or something, probably about $5. So I have 6 bands. I picked 80, 40, 20, 17, 15, 12. And then put the rig on one end, the antenna on the other, and then I figured out what matching network I would use for each band based on the impedance I measured on the VNA. So there's an example, and there would be similar networks for each of the 6 bands. That's kind of my favorite topology where it works. A pi network with a series inductor and 2 shunt capacitors. The nice thing about that layout is that it's a low pass effect. It blocks the harmonics, which is essential for some of the bands because I have it straight out of my homemade amp, which it's too dirty to be legal to transmit on the lower band. So I need low pass filtering in the matching network. And then inside it's a complete mess. There's the bottom of the switch there, 2 ports out here, and then there's the 6 networks in it. And then once the cover is on, it's like this, and I think it's dead simple. I could explain it to a 5-year-old in words of 1 syllable. I think you put the big wire here, the small wire here, turn the knob to point to the band you want to use, and it works well enough. There's seems like there's a bunch of de-expeditions going on at the moment, and I worked 3 of them in the last 3 days, This morning, TX6D, I think the Germans. Last night I got Tuvalu T2C, and the day before that, W8S, Swains Island, all of them through this match with a 5-watt output power through that bit of wire in my attic with a homemade transmitter and receiver. So it does the job. Thanks very much.
Thanks, Gary. AI7AW. And, you know, you looked at that and saw the wires all messy. I remember in high school shop, a kid built a kit and he made nice square corners. It never worked. I built stuff looked like Gary's, it always worked. So you got to remember, that's part of the RF tuning. All right.
Well, this is very basic and very old and familiar to everybody. It's the
Jacob's ladder.
Antenna. When I came to Anchorage, I left Anchorage, I went to Texas. When I got to Salt Lake, I had no tower, this was my antenna. Okay, now the J-pole, this is for 2 meters. It's a quarter wave tuned element, which is coupled into a half wave radiator. The quarter wave has a radiation pattern that looks like this. In other words, it's mostly going up in the air. The half wave has a radiation pattern that looks more like this, a lot of low angle. So that lets you work with a handy-talkie. That lets you work with a handy-talkie where you wouldn't be able to otherwise. There are all kinds of J-poles. You've probably seen millions of them. Here is another one. This one is made out of twin lead. And you've got the feed point down here, and you've got the one element, one side is cut here, that's the quarter wave, and then you've got a half wave, and you can throw this up in a tree or a roof or something. A little coil here, they're all supposed to have coils on them. What I use now on 2 meters and 440 is a J-pole. I can't take it apart, unfortunately, but it's made out of twin lead, just like this one. It's has a distinctive feature that the half wave element has a choke in it to shorten the half wave element to a half wave on 440. This thing will work on either band, but the radiation pattern is much better on 2 meters. It gets bad on 440. It's good for talking to airplanes. The choke here makes a big difference, and it lets you have the same kind of low radiation with the 440 that you would normally have with a 2 meter J-pole. And this goes in another piece of tubing, and I've got it up on a tetherball mast. And that's my current 2 meter UHF VHF station. This I got as a kit. It's very simple. If anybody wants the dimensions to build it, I can give that to you.
Looks like some copper-coated welding rod.
This is just, yeah, this is brass tubing. Okay, this is no, this is brass rod. It's not welding rod. It's brass rod, and it allows you to tune the 2 elements. You can tune the element lengths.
All right. One more. Okay, KI7PQR. have her coming down, and yeah, go ahead, real quick question.
My question is, where did you get that brass rod?
You can get it at craft stores.
Craft stores?
Like hobby store?
Brass rod is brazing rod, and you get the tubing from a welding hobby. Yeah.
All right. All right, I don't know your name.
Hi, my name is Vicky, KI7PQR.
Okay, Vicky, there's the mic.
Okay. I'm a little embarrassed because you guys have all got such sophisticated stuff. My multimeter does not have a conductivity tester in it, so I built one. This is my very first electronics project ever. I am a life sciences person. I like snakes. I like bats. I like toads. I am terrified of electricity. So doing this was a big deal for me.
You need me to hold that? Okay.
Can we put this where the camera can see it?
Yeah, okay.
Anyway, I wanted a tester that made noise because my hands wander off and do things. I didn't want to look up to see if the light was lit for a conductivity, but I didn't want a loud noise. My husband scavenges parts from everything, and he keeps them forever. So he found me an array of circuit diagrams. I picked the one I had parts for, and then and I put it together and I built it, and all my solders were good the first time. I'm amazed. So that's it.
Hold it up. No, to him, for the archives. Yeah, very good.
Nope. It's a coin battery, a little speaker off of a old computer, and then a transistor and 2 resistors, and that's all it is. I don't know if you can. It just crackles. Beep! Yeah, here. Let me open it. It just makes kind of a crackling noise, but it's enough for me to tell without looking up.
Yeah.
So.
Excellent. This is part of what ham radio is
nothing.
And it costs nothing, is building things, talking to people, making DX contacts, social events like this, and heck, by having the involvement of the club, you heard that the inspector in Holiday City was a ham. We need to get all of the people in zoning and as ham radio operators to make life easy for everybody. Good to see you, Tom. So I think that's it. Boy, we took up all the time. We had a few more people online, but unfortunately I think the people here had to take precedence over the online ones. Maybe if you run out of things to do in the future, we can do some online things. So I'll turn it back to, I have to look here and see which officer's going to pick it up. Thank you.
Thanks, Glenn. That's it for tonight, people. Don't forget to take a look at the books that Rick has got back there, but Rick is back again. Do you have any specials or anything, Rick? No? Okay. See you next month. Yeah, I was going to say that.